Electrons follow a set of quantum rules so strict and so elegant that the entire periodic table is built upon them. Today, we're going inside the electron realm to uncover those rules, such as Aufbau, Hund, Pauli, magnetism, and how photoelectron spectroscopy reveals it all. Electrons don't just sit anywhere they like. They fill energy levels starting from the lowest available energy. This is the Aufbau principle. Electrons occupy the most stable, lowest energy orbitals first. 1s fills before 2s, 2p fills before 3s, but because orbitals sometimes overlap in energy, you get patterns like 4s filling before 3d. This entire structure shapes the order of the periodic table. Here's a special case. When you fill up orbitals, the usual rule is lower energy gets filled first. You'd expect 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, but nature decides that 1s, so on and so forth, 3p, and 4s straight away before 3d. Why? Because when the atom is empty, 4s is slightly lower in energy than 3d. But after the electrons actually move in, 3d becomes lower than 4s. Hund's rule states that when filling degenerate orbitals of the same energy, electrons will first occupy each orbital singly with parallel spins before any orbitals are doubly occupied. This is to ensure that electrons remain as far apart as possible to minimize electron-electron repulsion. Hund's rule is very useful as it helps explain the magnetic properties of some elements and molecules. Scientists and engineers use principles derived from Hund's rules to design new materials with specific magnetic properties. This is important for technologies such as magnetic data storage, MRI devices, and various electronic devices. Whether an atom is magnetic depends on its electrons. Unpaired electrons are paramagnetic. These atoms are attracted to magnetic fields. All electrons pair diamagnetic. These atoms are repelled by magnetic fields. By simply counting unpaired electrons using Hund's rule and orbital diagrams, you can predict magnetic behavior instantly. So in this example we see here, a very common example of the molecular orbitals of oxygen, we see that there are two unpaired electrons in the pi antibonding 2p orbital, and hence oxygen is magnetic. Photoelectron spectroscopy (PES) is a technique that uses the photoelectric effect to measure the binding energy of electrons in atoms, molecules, or solids. It works by irradiating a sample with high-energy photons, which ejects electrons. By measuring the kinetic energy of these electrons and knowing the energy of the incident photons, the binding energy of each electron can be calculated. This results in a spectrum with peaks, where each peak corresponds to an electron subshell and its height indicates the number of electrons in that subshell. From Aufbau's building up pattern to Hund's spacing rule, from Pauli's exclusion to the magnetic signature of electrons, every quantum rule works together to build the structure of all matter, and with electron spectroscopy, we can probe those rules directly. Understanding these principles is like holding the blueprint to the periodic universe. Thank you.